Welcome to your geometry lesson on transversal angle pairs. Today we'll start with a quick review of two previous angle pairs we learned about. The first being vertical angles. Now vertical angles are a pair of non-adjacent angles formed when two lines intersect. In this figure, we have two different pairs of vertical angles. If we look first at angle 1, it is adjacent to 2 and 4, but non-adjacent to angle 3. Therefore, angle 1 and angle 3 make up a pair of vertical angles. Now we also have another pair of vertical angles, being angle 2 and angle 4. So then our other pair of vertical angles is angle 2 and angle 4. We learned about another pair of angles. Those are linear pairs. Those are a pair of adjacent and supplementary angles. So when you look at a picture like this, we have a straight line made up of two angles. In this case, angle 1 and angle 2. That makes angle 1 and angle 2 a pair of linear pair angles. Now we also have a couple different ones here. You could also look at this way, that angle 3 and angle 4 would be another linear pair. And if you keep going around, there's a couple different other ones. For instance, we could do 1 and 4, as well as 2 and 3, making up the other linear pairs in this figure. So as a quick review, there's two different pairs of vertical angles and four different pairs of linear pairs when two lines intersect. Now today we're going to look at what is called a transversal. By definition, a transversal is a line which intersects two or more lines at different points. So in our figure here, we have lines M and N that are intersected by line T at points A and B. Line T is the transversal of lines M and N. Now, regardless of how the lines are positioned, line T is still the transversal. It can also intersect not only two lines, but three lines at different points. In this case, line T is the transversal of lines M, P, and N, intersecting at points A, C, and B. Now, sometimes pictures can be a little bit more complex. So in this case, we can look at it different ways. If we look at line M is the transversal of lines N and P intersecting at points A and B. But we can also look at line P. In that case, line P is the transversal of lines N and M intersecting at points P and B. And lastly, we can look at line N. Line N is the transversal of lines M and P, which intersects those lines at a point A and C. The more important piece of this is being able to identify the transversal angle pairs. First, we'll talk about two major points of vocabulary. The first is interior angles. Those are all the angles that lies between two lines. In this case, lines P and Q. In that case, there would be all angles inside. So in this case, Angle 4, angle 3, angle 5, and angle 6 are all interior angles. Besides interior angles, we also have exterior angles, and those are all the lines that are not between the two lines, being the space here and here. In this case then, angles 1, angle 2, angle 7, and angle 8 would all be considered exterior angles. From the basic idea of interior and exterior angles, we also have words such as alternate and consecutive. The first way this works is we look at alternate interior angles. Those are non-adjacent interior angles that lie on the opposite sides of the transversals. The key here is to understand that alternate means opposite sides of the transversal. So if we look at this, an example is angle 4 is on the opposite side of the transversal as angle 6, while also being non-adjacent. So in this case, angle 4 and angle 6 would be an example of alternate interior angles. We have one more alternate interior angle pair, being angles 3 and 5. Besides alternate interior angles, we also have alternate exterior angles. Those are the non-adjacent exterior angles that lie on opposite sides of the transversal. Likewise, this idea of alternate being opposite sides of transversal still exists. In this figure, we could look at angle 1. Now we either have to use angle 8 or angle 7, and angle 7 is also on the other side of the transversal or alternate. So angle 1 and angle 7 is a pair of alternate exterior angles. We also have another pair, being angle 2 and angle 8 are also alternate exterior angles. Another pair of transversal angle pairs are consecutive interior angles. In this case, those are interior angles that lie on the same side of the transversal. Key point being here that the word consecutive usually means that they are on the same side of the transversal. So looking at our figure, if we look at, for instance, interior angles, like angle 4, it is on the same side of the transversal as interior angle number 5. Therefore, angle 4 and angle 5 are a consecutive interior angle pair. Then we also have angle 3 and angle 6 being the other pair of consecutive interior angles. Angle pair is corresponding angles. These are angles that lie on the same side of the transversal with one interior and one exterior. This can be a little tricky, but if we look first at angle 1, it is on the exterior. The only other angle that is not on the exterior, but is also on the same side, is angle 5. So angles 1 and 5 are a pair of corresponding angles. We also have several other ones. For instance, angle 4 is an interior angle. It is on the same side of the transversal as angle 8. So 4 and 8 are another pair of corresponding angles. And then we have a couple others, being angle 2, being a corresponding angle with angle 6, and angle 3 being a corresponding angle with angle 7. Let's take a look at a couple examples which build upon the transversal angle pairs. In this problem, we're going to use the figure. What we need to do is classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior. So let's first start by looking at angles 1 and 5. If we look at angle 1 and angle 5, they're using this line as a transversal. In this case, they're both on the exterior, meaning that they have to be a pair of exterior angles. Now the only one, and you can also see that angle 5 and angle 1 are on different sides of the transversal highlighted in red. So in this case, angle 1 and angle 5, alternate being different sides of the transversal, they're alternate exterior angles, which is commonly abbreviated with the AEA. Now in the other ones here, in B, we're looking at angles 3 and 7. If you look at 3 and angle 7, they're using, again, the transversal here, and they are both on the interior of the other lines the transversal intersects. Likewise, they're also on different sides of the transversals. So in this case, angle 3 and angle 7 are alternate, being on different sides of the transversal, both on the interior, so they are alternate interior angles, abbreviated with the AIA. Now, if we quickly look at some of these other ones, we can also look at angle 6 and angle 7. If you look at 6 and 7, they are actually on the same side of the transversal, but they are both in the interior. Therefore, angles 6 and 7 are a pair of consecutive interior angles. If you look at letter D here, we have angles 5 and angle 7. So if we focus on angle 5 and angle 7, you'll notice one is on the interior and 5 is on the exterior, with them both being on the same side of the transversal. In that case, these would be corresponding angles. Then if we look at angle 2 and angle 4, they are also on the same side of the transversal, with one being interior and one exterior, so that angle 2 and angle 4 are also corresponding angles. If we look at angles 4 and 8, 4 and 8 are on different sides of the transversal, so that they have to be alternate angles, and both are on the exterior. So 4 and 8 are alternate exterior angles. Then we look at angle 2 and angle 6. They are alternate, different sides of the transversal. They are both in the interior, so they are alternate interior angles. Let's look at two example problems which builds upon the transversal angle pairs. In this problem, we're going to classify the relationship between each angle pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior. For question A, we're looking at angles 1 and 5. So if we look at angle 1 and angle 5, we can see that they're using this as the transversal. In this case, they're on different sides of the transversal and both on the exterior. So these would have to be alternate exterior angles, commonly abbreviated with AEA. In question B, we're going to look at angle 3 and angle 7. Now they're also going to be using this line as your transversal. They're both in the interior and they're on different sides of the transversal. So these have to be alternate interior angles. On question C, we're looking at 6 and 7. 6 and 7 are on the same side of the transversal in both interior angles. So by our definitions, this has to be a pair of consecutive interior angles, abbreviated with the CIA. The last one, or the next one, we have angle 5 We're looking at angle 5 and angle 7. Angle 5 and 7. In this case, one is on the interior, one is in the exterior, and they are on the same side. If you look over our angle definitions, this makes them a pair of corresponding angles. On letter C, we're looking at angles 2 and 4. Now these are also one interior, one exterior, and on the same side of the transversal, so these are corresponding angles once again. Then we're going to be looking at angle 4 and angle 8. In this case, these are both exterior angles on different sides of the transversal. So angle 4 and angle 8 are our alternate exterior angle pair. Now if we look at question G, we're looking at 2 and 6, which are alternate angles since they're on different sides of our transversal, and both in the interior. See, these are alternate interior angles. And for our last question, we're looking at angle 2 and angle 3, which are on the same side of the transversal, both in the interior. So these are consecutive interior angles. In example problem 2, we are asked to generally identify the relationship of each pair of angles, and then if necessary, identify the transversal connecting each pair of angles. We're going to start by looking at angles 1 and angle 2. Now in this case, they're not connected by a transversal, but this is one of the angle pairs that we reviewed at the beginning of the lesson. These are vertical angles. To have vertical angles, there are no transversals, so it's not necessary to identify the transversal. If we look at B, we're going to look at angle 2 and angle 4. And in this case, you can see they're not made by intersecting lines, but they're made by line A acting as a transversal. In this case, angle 2 and 4 are both on the same side of the transversal and both in the interior. So these are consecutive interior angles with the transversal of line A. Next, we're going to look at angle 4 and angle 5. In this problem, they are connected through line D, with both being interior, but also they're going to be both on different sides of the transversal or alternate. So these are alternate interior angles with the transversal of line D. Next, we'll look at angles 6 and 7. So finding 6 and finding 7. And in this case, they're not connected by a transversal, but they're adjacent and create a straight line. So remembering from our review, these are a linear pair, abbreviated with that LP. Linear pairs do not require a transversal, so in this case, there's no need to identify a transversal. The last few here, we also have angle 7 and angle 8. Now these are connected by this line E acting as transversal. It can be difficult to see, but 8 is the interior and 7 would be on the exterior. They're on the same side of the transversal, so these would be corresponding angles that use line E as the transversal. Looking at angle 2 and angle 3, they're connected by this line A. With both being interior angles and being on different sides of the transversal, these would have to be alternate interior angles with line A as the transversal. And in the last two, we have angles 7 and 9, which use line E as a transversal. They are on different sides of the transversal and also both exterior. See, these are alternate exterior angles with line E as a transversal. And lastly, looking at 6 and 7 again, which are actually just a repeat of problem D. So then these are just have to be a linear pair again with no transversal. That concludes today's lesson. Make sure to complete the checkpoint problems to check for your own understanding. Thank you for watching.